Welcome back to my channel. Now, have you ever wondered what's common in between a butter melting on a pan and you saying that you have burned your hand when you just touched a rock which is sitting outside on a hot summer day? Well, if you said that the answer is heat transfer, bingo, you're correct. Okay. Now, that's what we're going to be talking about today, heat transfer. There are three different types of heat transferring ways: conduction, convection, and radiation. And that's what we're going to be learning about. So, first, let's start with conduction. Okay, so there are two conditions for conduction. And the first one is that the two objects have to be of different temperature, one hotter and the other colder, right? And the second one is that the two objects have to be in close proximity or touching each other. Okay? So those are the conditions for conduction. Now, we're going to dive a little bit deeper into conduction a bit later. But now, let's go to convection. Okay, friends. So, what is convection? Well, convection happens with fluids, and that I forgot to tell you that conduction normally happens with solids. But anyway, let's get back to convection. Convection happens with fluids, which means liquid or gas. Now, one example of convection would be boiling water in a pot. Okay, so let me tell you how. Now, if you have water in a pot and you put it on the stove, what's happening? Well, you know that the water below the pot, like not below the pot, but like water towards the bottom of the pot, is going to be more heated up than the water above the pot because the fire is below the pot, right? So that's why the water which is closer to the bottom of the pot is going to be hotter. Now, if the water is hot, that means it will rise up. So that means this hot water which is below is going to rise up. And now, you know that the water above was cold, right? So that cold water is going to sink down. Okay, friends. Now, what's going to happen? Well, now the water that was initially cold is closer to the heat source. But the water that was initially hot is, well, it's further to the heat source, right? Well, now what does that mean? The water that's initially cold is going to get warm, and the water that was initially warm is going to get cold. So then the water that was initially warm is going to sink down, and the water that was initially cold is going to rise up. And now this happens again and again and again and again, leading to the water boiling, right? And this also causes a current called the convectional current. The same current that is there when you turn on the AC. Okay, friends. And last, have you wondered about about a type of heat transfer that doesn't use molecules or particles? Well, it's because both conduction and convection use molecules or particles. Well, that way is radiation. Okay, friends. So, what is one area without any molecules, without any particles? Well, one area like that would be space. Space is a big vacuum, which means it has no molecules or no particles. Okay? Well, still, the sun is in space and its heat is very major to the earth. So, how does the sun's heat travel? Well, through radiation. And what does radiation use? Well, it uses electromagnetism or electromagnetic, and that's how the sun's heat transfers. Okay, friends. Now, as I told you, we're going to do some experiments to prove conduction. So, let's start. Okay, so over here I have a candle. Okay, I think that's good enough. And over here I have a spoon and a butter. Okay, now I'm going to hold the spoon right there, right next to the candle, and I want you to guess what's going to happen to the butter. Is it going to melt or is it going to just stay there? Yeah. Well, before I could even finish the question, the butter has already melted. See? Okay. Okay. So the butter has already melted. Now, let me tell you how. Well, it was through conduction, of course, but let me explain a bit deeper. Okay, so the candle is a heat source, correct? Right. Okay, so now that candle is going to transfer its heat to like the metal spoon. Now the metal spoon is not a liquid to just flow away. It's solid. Now, before I tell you about this, you know that this heat is going to give kinetic energy to the particles of the spoon, right? Yeah. So then, what can the molecules in the spoon do? Because it can't fall, well, instead it will vibrate. Now, when some molecules vibrate, it will hit the molecules next to it, and then those molecules start to vibrate. Now, those molecules are going to vibrate and hit molecules next to it. And this is going to happen again and again and again until it hits the butter molecules. And when it hits the butter molecules, what happens? Well, now the butter has the heat energy in it. And so the butter melts. That's what happens, friends. Okay, now the next experiment, I have a balloon. And I'm going to try to get it in contact with that fire. Oh my god. So that balloon did burst, and let's keep that candle over there for now. Okay, friends, now the balloon bursted. And I actually did not get in contact with the candle before the balloon bursted. And let me tell you how. Well, there's the candle, the heat source, and the candle is warming the air molecules around it, right? Now, as you know, when air molecules are warm, what do? Well, they rise up. So now these air molecules, which are heated up, are rising up. And when it gets in contact with the balloon, it tears a hole in the balloon, and then the balloon bursts open. Okay, friends. So that's how the balloon bursted open even before I got in contact with the fire. Well, the balloon got in contact with the fire. Okay, now over here I have 2 glasses. Okay, now I'm going to pour cold water into this one and very hot water into this one. So let's start with this. Oh god. That's good enough. So that's steaming hot water, as you can see. And this is very icy cold water. There's ice in there. So let's see. Let's try to get the same amount of water. Oh god. My hands are cold now and hot too. Okay. Now over here I have red pigment. And I'm going to put the red pigment into both of these. Okay. So I put 2 drops into both of these. And now what I want you to do is just watch what's happening. Okay, so let's just do it for a little bit of time. But as you can see, over here for the hot water, the pigment is mixing way faster than the cold water. Okay? So this is the condition of the hot water, almost completely mixed up. This is the condition of the cold water, not really mixed up. Okay? Barely mixed up, and the hot water is almost mixed up. Okay, so friends, now what does this prove? Well, this proves that the hot water has more kinetic energy than the cold water. Why? Well, first let me ask you, how is this pigment even mixing in with the water? Well, that's because the particles have a bit of kinetic energy, right? And so when the particles are moving around with the kinetic energy, moving around, the pigment just moves around with it. Now, because the hot water has more kinetic energy than the cold water, that's why the pigment mixed in faster for the hot water than the cold water. Now, just so that these two mix up pretty evenly, I'm going to take a spoon and mix both of them for right now. Oh, okay, friends. Now, what I'm going to prove you now is, remember when I told you in the first experiment that it was the molecules were vibrating and then hitting another molecule, and those molecules were hitting another molecule and making everything vibrate? Well, can I prove that to you? Well, yes, I can. And how do I? Well, I'll show you. I have tissue paper which I folded and then I stapled it to make it stay in this position. I'm going to insert both of the tissue papers into the hot and the cold water. Okay? Oops. Let's see which one travels first. Okay, friends. I don't know if you can see it, but the hot water is winning the race. I'm gonna wait for 5 more seconds. 3, 2, 1. Okay. So it's obvious that the hot water won the race. See? So for the hot water, okay, there's water right there. But for the cold water, when it comes to the same position, no water, no water. Water comes over here. So, well, that shows you that it was moving in a chain fashion, right? Because if you could see, the water was moving gradually, up, right? So that shows you that it was moving in a chain fashion. And it also shows you that, again, hot water, well, has that more kinetic energy, more heat, right? So that's why the water is going up faster than the cold water, which is only going a little bit up. So the winner for this competition, hot water. Hooray for hot water. Okay. Okay, friends. Now, the next experiment I'm going to show you is, well, that the difference between different types of solid. So, just because two things are solid doesn't mean that for one of them will have less conductivity than the other. No, I'm sorry. One of them will have the same conductivity as the other. Solids don't have to have the same thing. And I'll tell you what I mean a bit. Okay, so now I have a question for you. Do you think that all solids have the same thermal conductivity? Well, let's see about that. So, over here I have a plastic spoon and a metal spoon, which both have butter on it. And I'm going to put plastic spoon there. Oh my god. I'm so sorry about this, people. Okay, I'm gonna put the plastic spoon there. The metal spoon here. And the plastic is trying to float, so I'm gonna hold the plastic over here. So I'm gonna wait for a bit of time and see which one's butter melts first. Okay, friends? So I'm gonna wait for about 20 to 25 more seconds. Okay, guys, so it's been a bit more than 25 seconds. So let's see how both of these are. Oh god, this is smushy. So as you can see, this is very smushy. And my hands are covered with butter. It's very easy to smush it, just touching it smushes it. See? So it's almost melted condition. And I'm gonna wipe my hands. Okay, friends. Okay, let me wipe my hands a bit more. And then for this one, let's see. Okay. So this is a bit more solid. It's not really melting in my hands. It's more acting like Play-Doh. It's not really melting. Okay? So even if I press it this much, it's just going around. It's not like melting in my hands like the other one was. So yeah, now I'm gonna wipe that here. Okay, friends. So bye. Bye. Hope you liked this video, and don't forget to subscribe and share this. Subscribe this channel and like this video and share this video. Bye.